doing it, then we have to ask.
Yeah.
Hello.
Hello. A very good afternoon to one and all present here. Welcome to the day 2 of Bootcamp on Cybersecurity. So let me introduce you all to our speaker for the day, Mr. Ash. He is a DevOps security analyst at Race Financial Service. He's a cybersecurity consultant at Chitle Bandhu Mithai Wale. He has done cyber investigation and research internship 2021 in Key Cyber. So let's welcome Mr. Ashutosh with a huge round of applause.
You. So today we are going to cover few other cybersecurity topics like cryptography, encryptions, and basics to web security. But before we initiate these topics, first I would like to know how many of you are from cybersecurity? Okay, and remaining others? IT. Sorry, all are from IT. Okay. So you are from cybersecurity, which year actually? Second year. So you guys being aware of what cybersecurity actually is, right? So can anybody tell what actually cybersecurity is according to you guys? What do you mean by cybersecurity? Let's make this session more interactive. What do you mean by cybersecurity in according to you? What's your definition of cybersecurity? Anybody? Protection of computer systems. Okay. From malwares. Okay. Anything more? Is cybersecurity only limited to protecting our system from malware, some viruses, and thefts? Oh, or yes.
Protection of data is more important.
Okay. Fine. Understanding is protect systems, data, and protecting ourselves from hackers and all this stuff. Okay, fine. So the thing is, cybersecurity is not only limited to protecting our systems, not only limited to malwares and viruses. It is a vast domain. It consists of various different subdomains, like it consists of digital forensic, malware, web security, Android security, digital forensic, and cryptography, encryptions. There are multiple different domains which available over there, right? I'm going to talk about things. There are so much stuff to cover within a span of 2 hours, 2 days, or 2 weeks. All right. But still, we're gonna try to cover at much we can cover regarding the cryptography today. So before we start with the session, anybody here having any rough idea about what cryptography actually is? Encoding, okay. Hashing, Okay. Have you heard cryptography previous somewhere? Can you suna hai? Cryptography, encryption, Caesar cipher, encryptions. Okay, WhatsApp, the end-to-end encrypted messaging. Fine. So we always learn cryptography, always heard cryptography about security, encryptions, end-to-end encrypted social medias. A part of them, we heard about hashing, MD5, BAS64, encoding, decoding, encrypting, decrypting, right? But all of this stuff come under the one roof that is called as cryptography. So when we talk about cryptography, okay, so first let's see what are the topics we're going to cover. Okay, like you have to go upward or
Yeah, fine.
okay, fine. Cool. So in today's session, we're going to talk about cryptography, what actually cryptography means, what are the different type of cryptography algorithm that is encryption algorithms. We are going to talk about public infrastructures, digital certificate. We are going to take some hands-on lab. We are like going to make our own SSL certificates. We are going to perform encryption and decryption with ourselves only. After that, then we are going to talk about web security, a bit of web security. We're going to initiate like what actually web security is. So starting our session with our first question, what is cryptography? Okay. Is it visible? Okay, it is now. So while we study the actual definition of cryptography, it says that cryptography is nothing but is the art of protecting the information by transforming it into an unreadable format. Okay. So when we talk about cryptography now, it is been like carry forwarding each every year. Like it's not from like it invented few years back or something. We are using cryptography since decades, not decades, sorry. We are using cryptography since ancient times also, right? So, can you just give me a simplest example of cryptography you ever seen or heard or you know about? Simplest form of cryptography, apart of any algorithm. Cryptocurrency is something different though. See the cipher, okay. Even more simpler than that. Let me give you an example. For example, let's say you go to US. Okay, you go to US with your friend. In US, you and your friend both talking in Marathi so that nobody else can understand what you're talking about. That's nothing but cryptography. You are hiding your data so that you and your partner only both can understand what's going on there. No third person going to understand, right? So this is also example of cryptography, but here very simplest form, no more security concern is been taken. It is really like listen to someone else. If he know Marathi, he can like understood what you're talking about. So that's a different factor. Like here, no security impacts. There are lots of impacts over here, but still, it is the simplest form of cryptography over here. Right? So when we talk about cryptography, it's nothing but it's an art. What the first slide say is cryptography, the art of secret writing. It means whenever we are like communicating, we are passing the information to person A to person B. It should be remain between both only. No third person should know what the information is passing between. So the art of making the things happen is called as cryptography. So okay, the PC is lagging a bit. History of cryptography. Uh, Cryptography is being used from the ancient time, but when computer was not there, how like cryptography was using and how it was like being introduced to the world. How we come to know about Caesar ciphers, how we come to know about different cryptographic tools like Skype labs, Caesar ciphers, uh, visionaries, etc. Multiple cryptography algorithms, right? And they are into like process since I guess from 1200 BC something. Initially, it was being introduced by the Greek king actually. So it was there are several stories actually behind this. Uh, okay, we can understand like what's the why there is a need of cryptography over there. With the help of a small story, you can say. So let's say there is a kingdom. Okay, in a kingdom there is a king. We can name the king anything like we can take the name of any person like Modi. And he has his like few mantris to whom he want to like communicate today. He want to communicate regarding his power, his secrets about his defense, finance, and all those stuff, right? So for communicating, he have to like send in the letters or like that. That varies me. He used to communicate with his mantris. Okay. So the thing is, while he was once what happened is like uh, there was few spies which come from the neighborhood countries. Okay, what they did, they just entered the country and they just anyhow get to know what are the information the Modi is passing to his mantris. Maybe the information is regarding the defense. Maybe the information is regarding how the security is over there on the borders and all, right? So they get to know the informations which Modi is passing to the Mantri, and they give this information to their neighborhood king. And the neighborhood king, which is the enemy of the Modi, attacked on him and he conquered because he get to know the sensitive information which has been transmitting between Modi and his Mantri, right? So this is not one story. There is multiple stories regarding this, but the base over there is common. Is like there is a need of cryptography because there is also not a secure channel or like where a two-person can communicate in a securely manner. If okay, we can take different examples also. Like if I want to talk to my friend previously when there was not a TV or when there was not a mobile phone also, we used to write letters. Right? We used to write letters, and also there was an era where we used to use pigeons. That कबूतर जा जा जा. Everybody know कबूतर के पैर पे बांध देना, इसको भेजना. And that was the era जब हम letters कबूतर के साथ भेजते थे with the help of the pigeons also. So in that also the message can be like can be like it can be delivered somewhere else. Like in between, neighbor can capture the pigeon, he can kill it, and get the messages. What is one king is passing to another king, or the message which is passing between two peoples. So anybody in the between can capture it, can get to know what's the message transmitting, right? So there was a need to make a secure channel. So what was introduced there is like when we're talking about Mantri, in that case, when the neighbor country won. So what held a meeting, and in the meeting, held meeting with a few of those like trustworthy peoples where they came up with a like you can say a technique. What technique it was? It was like we're gonna substitute the letters front and back. Let's say if I am using A B C D, okay, I am using hello, HELLO, hello. I am sending hello. So I gonna substitute the letters three letter ahead. So instead of H, I'm gonna send HIJK, IJK. Instead of E, D, ABCD, F, G, H, H. Okay. So like I have not written in the PPT if I'm no. So like you got what my point is, right? So the method they introduced was called substitution method, where we also use this method right now till now also that is known as Caesar cipher. You said right? In Caesar cipher, we do the same thing. We substitute the letters with a few letters ahead, a few letters back. So that is one of the type. Apart of them, there was one more technique that I was using called as kite lab. So in which what they are doing is like, let's say I'm holding a pen, maybe this bottle. Okay. Here, what I'm gonna do? I'm gonna wrap this bottle with a paper. Okay. After wrapping, I'm gonna write the message whatever I want to transmit. Let's say after wrapping, I'm writing a hello, or let's say hi, if a hello or anything. After that, I will unwrap the paper. After unwrapping, it's gonna look like nonsense. What's written over there? Half liter here, half liter here, half liter here, right? But when I will transfer this message to my partners, like this person B, I have to tell him what is the diameter of this bottle or its pen is. So he can hold the same. He can hold the object of the same diameter. He can wrap again, and when he wrap again, he gonna see like what was the actual message written over there, right? So this was the one of the more technique used in the ancient period, called as kite layer. So a part of that also there are various different methods. We also don't know many of the methods that was used in the previously for the cryptography. We get to know many ways. Actually, the thing is now in the recent research also, few of the techniques has been discovered which was also used previously in the ancient time for cryptography, which we are going to like learn now. We are going to get it now. Like हाँ भाई ये भी होता था पहले. इस तरह से पहले मैसेज एनक्रिप्ट होते थे. I am getting to know about more right now. While we're talking about ancient. Okay. Okay. Very good. I don't know why the PC is lagging a lot. Okay, so right now we had covered the history of the cryptography, where we get to know about cryptography has been used from the since 1,000 year back also. After that, we're gonna know about okay, there was one thing I like missed in this also. During the World War II, there was a machine was also like for cryptography. The machine called as what's the name Enigma machine. Anybody know about it? I heard yes from someone. Anybody know about Enigma machine? Lying a lot. I think your PC is lagging a lot. Yes, definitely. टाइम लगेगा. चलिए फाइन. ठीक है, अभी गाड़ी फाइन. Okay, we have seen the how cryptography was used in the ancient period, but after the ancient period, during the sorry, not aerial, during the early stages, like before medieval period, 16th, 17th, 18th century, there were a few different cryptography techniques that was in used are like mentioned over here. It's blurry over there. Okay, mentioned here as like substitution cipher, transportation cipher, and Skytel. I talked about Skytel right now, if you remember. It's called as Skytel. modern cryptography methods. So as the technology evolved, we are getting the access to we can do a lot of combinations and all. So since technology we use for the combinations, we are also like announcing more cryptography techniques. So right now we are using cryptography in two ways, in symmetric as well as asymmetric key algorithms. So actually, when we talk about cryptography right now, so the thing is we have discussed the cryptography is nothing but like it's similar to encryption. So encryption and cryptography, which means just putting our plain text into some different formats so that we can't read it easily, we can't get understood what actually written over there, right? In such a manner, using different mathematical algorithms or using different techniques. That's all about cryptography. So when we talk about the modern cryptography methods we use today, so in today used different methods like symmetrical algorithms as well as asymmetric algorithms. We are going to cover these topics in the next slides, next few slides actually. So when we talk about types of cryptography, so there are majorly three types of cryptography that have been used widely when we talk about cryptography, like symmetric key algorithms, asymmetric key algorithms, as well as hash functions, right? So what the symmetric key cryptography is? Like it's been covered in your syllabus or it's like new to you all? It's new? Great. What do you mean by symmetric? Anybody? We have heard about symmetric in 12 also. Straight line. Anything else? What symmetric is? About this in 12 also. There in biology, I guess there was a symmetrical division, right? Okay, so let it be. Symmetry is nothing but anything which we can divide into two equal and same part, right? Next we call symmetric. So in the same scenario, when you talk about symmetric cryptography, what it means is like let's say I want to like transmit my information in encrypted format. So the key which I'm using for encryption, the same key is going to use for decryption also, right? Oh, okay. Okay. Perfect. We were talking about types of cryptography. So in cryptography, as I said, there are majorly three types: symmetric cryptography, asymmetric cryptography, as well as hash functions. So if you just read the definition of these three, what actually they mean is in symmetric cryptography, we always use the same key for encrypting as well as for decrypting. It's more like this. I believe you know this lock and key, right? Where we use the same key to lock the lock as well as to unlock that lock, right? To open and lock, close, or lock, right? So when we talk about the symmetric encryption, in symmetric encryption, we use the same key for both encryption and decryption. It is even faster than asymmetric encryption. So what do you mean by asymmetric? So it's just completely opposite than symmetric, right? In which the both part are not unequal, are not same, right? So when we talk about asymmetric cryptography, in asymmetric cryptography, you use different keys for encrypting and for decrypting the messages. So in this case, we can take the example of lock like this. So in this lock, what happens is like whenever we close the door, it's gonna lock automatically. But if you want to open the lock, we have to pass a secret key. We have to pass the card, or let's say verify the card, or else we have to like use the key, right? In a similar way, for asymmetric encryption, we can use two keys, like for encryption as well as for decryption also. So in this case, while talking about asymmetric key encryptions, or let's say asymmetric cryptography, we use public key as well as private key. Public key for encryption and private key for decryption. So asymmetric cryptography also called as public key encryptions also, right? Okay, everybody on the same page? Any doubt? Great. Now talking about hash functions. So what actually hash functions are? So hash functions are like used to like make sure the integrity of the data or software. So whenever we download any software from the internet, let's say whenever we are downloading Windows or Linux, every time we are getting some hash keys over there. We can verify that hash key so that we can make sure the file we are downloading is the actual file present over there. Like in between the downloading the process, no data has been interchanged or intercepted in between, right? So in order to make sure that the integrity of the data is maintained, that the data जो मैं originally भेज रहा हूँ from the while sending data, वो जो state में था, जब वो data पहुंच रहा है, when it is delivering over the person B, it is same, actually the same, and like nothing changes in between. So for that, what we do while sending the data, I will just create a hash of that data. So hash can be like anything. It can use MD5 or SHA and there are different algorithms for hash functions. So using the hash, using the hash functions, I will get a hash while sending the data. And once the data delivered to the user, again the hash gonna be like generated in if both the hash are same, like while sending and while delivered, then we can make sure that the data sent over there is like safe and it has not been intercepting in between. Correct? So that was the hash function was. But a part of these three techniques, there are different other types of cryptography also. There are other different types of techniques for cryptography also, like digital signatures, digital certificates, SSL, and all. All right. So while talking about, okay, so I had done here the example of scissor cipher. Initially, when I was talking about the cryptography used in the ancient period, so we had seen this scissor cipher. Scissor cipher is a like type of this symmetric as well as substitution cryptography, where what we do, we just replace substitute the letter with some different letter or number. Okay, so in this case, why scissor cipher is a symmetric encryption? Anybody? Why we say that scissor cipher is also a part of the symmetric encryption method? For that, we get to know like what actually symmetric key is. What a symmetric encryption algorithm is. We just covered symmetric encryptions. Symmetric encryption is the same key for both encryption as well as decryption, right? But in the case of scissor cipher, we substitute the letters, right? So in this case, what is the key?
Number of
Letter we are substituting. Let's say 3 forward or backward or any number that is forward or backward, right? So that is the key. Good. So the thing is, while we are talking about the scissor cipher, in this case, the secret key is nothing but the number of digits or letters we are like moving ahead or going backward. So that number is the key we are using for encryption, and that same number is going to be used for decryption also by the second party, right? Great. Now, in the case of Skytail, Skytail is also a type of symmetrical encryption. How?
can hold it in the same thing and remove it in the same.
What is the key in this case? Because for symmetric
Diameter.
diameter. Perfect. When we're talking about visionary cipher, anybody know about it? What is visionary cipher? Any idea? Ever heard about it? By mistake, I read it somewhere. No? No idea.
Second, next letter.
So while you talk about the Vigilant cipher, it is a complex. Okay, I speak like this. It's fine. Perfect. So while you talk about Vigilant cipher, in this case, what happens is like, let's say my plain text. Okay. So before that, do you know what is plain text, ciphertext, secret keys? What are the plain text? What are ciphertext? And what are secret keys? Okay. The plain text is nothing but the raw data which we want to transmit. Okay. If I want to say hello to partner B, so the hello is nothing but a plain text. Okay. When I will use any of the encryption algorithm to encrypt this hello into I want to encrypt this. So for that I need a key. So that is nothing but my secret key, right? After using this, using secret key and algorithm, that hello gonna convert it into different format. That is the ciphertext, right? So the encrypted text is nothing but the ciphertext. All right. So in this case, while we're talking about the Vigilant cipher, let's take an example for hello. Okay. So we're gonna write hello. We're gonna find H from here and from here. See, ended up at O. Our first letter is O. Similarly, when you talk about E, I, O, I. You got two letters. HELLO. Double L right here. The word L, L, W, W. But we don't repeat the same letter twice. So we will add a jump. What the jump gonna be? It can be X, Y, Z. Okay, we take the example X. We take the jump as X. Okay. So what we get? O and for I O E I W O E I W X W
IWX.
W.
Okay.
For H, I guess there is O. For E, there is I. For HEL, for L,
W.
W.
OIW.
OIW, then X as a jump. Again L, there is W.
Okay.
HELLO. Then for O, we have O here. C.
OIWX. So
You got the ciphertext, right? But in this case also, we have secret keys. So secret keys is like here the arrangement over there is like in a similar way. So we can like change the arrangement. Let's say I take the secret key as order 5. So I'm gonna replace this by this row. It can be more messy. Or else I can make some different permutations or combination over here. Let's say for hello, I can take different examples. Like I can add hello like this, like this. Okay, we can take this. I can like explain you. Let's say example 1, 2, 3, 4, 5. Okay, consider ABCD and 1 to 10, 1 to 26. Correct. Write 1 to 26 like this manner. When HELLO, we got the rows. We're gonna alter the rows randomly. Let's say for example, I'll just consider it ascending order. So what you're gonna write? E, then H, then L, then O. Right? If let's say my ciphertext is like here the number is like 42315. So for hello, I will write first this letter, then this letter, then this letter, then this letter, then this letter. So that's like yeah, okay. Yes, marker I know. Then marker, so I can write down. Okay, fine. So I just want to let you know the basic idea regarding that. I hope you got it, right? So we have seen few examples of cipher, but why the cryptography is important? Why actually the cryptography is important? Come on, it is always also written over here.
We hide the data. So that data can be
Okay, to protect the data from the third party. A part of that.
Keep it confidential.
Have you heard about CIA trend? CIA, confidentiality, integrity, authenticity. Right? Right? So the main aim of cryptography of encryption is nothing but to maintain the CIA, to maintain the confidentiality, to maintain the integrity, and also to maintain the authenticity. Right? Okay. What are other main goals? Second importance to mention over here is like to protect the secrets and the services and the sensitive informations. Third word is written over in this cryptography in securing the modern channels, modern communications, right? A part of these three, what do you think? Why we use cryptography? You guys using cryptography, right? Into day-to-day life? Yes or no? Yes. A part of social media? Yeah, I consider this like WhatsApp is there. Hey. Code words. Maybe. Code word between best friends. Okay. Everybody use browsers, right? In browser, you visit any of the website, right? Any website. I'm not targeting any website. Let's say google.com. Google.com, simple. Okay. So whenever you visit google.com, there is HTTP or HTTPS? HTTPS. That is secure layer. Secure layer that is being used by using SSL certificate. SSL certificate is nothing but your digital certificate that is verified using digital signature as well as a private key and public key, which is nothing but the cryptography. Right? Right? Anything else? और कहाँ पे यूज करते हो cryptography? और कहाँ पे यूज करते हो cryptography? Okay. Account को login करते हैं. We used to log in the accounts like social media accounts or any of the accounts. We enter the passwords. The password gonna store in the database. It is not in a plain text. It always stored in a form of encrypted way, right? So, like, see, the thing is, for now, every technology is like used to handle the security part. And while you're talking security, the main goal, main objective of the security is CIA trends. They have to like follow the trend. So for that, they have to mention the confidentiality, their integrity, and authenticity. And for that, encryption is must, right? Okay. Okay, before going there, sorry. We were talking about this, which is cipher. Have you ever saw this puzzle like this? If edge A C or equals to something like B 5, then what will be M A N? You have solved puzzles like this, right? Similar to this, like if this represent 20, this represent 30. I think what's it called? If you solve this quiz, your IQ is 100 plus. Right? So in that case also, directly or indirectly, we are been practicing the techniques of cryptography. Right? What we do, we just find out the logics are going over here in HHC. If we compare HHC letter 8, so there is 10. there is increment of 2. Similarly, if there is 1, there is 3, increment 2. Similarly, we crack the code, then we can write for man, right? So in the same way, here we found the vulnerability in this, not the vulnerability, we found a technique how to crack these codes, right? Similarly, since the ancient period, the cryptography is being used, but still, every time the new techniques come, there is some loophole within them, which can be cracked easily. That's why every time there is a need of new techniques, new techniques, new techniques. Right now, if you talk, there is a research going on regarding the quantum encryptions, quantum cryptography, which can be done using quantum computers with the heavy computation powers, right? Because the existing cryptography algorithm which is in the market is somewhere like, you can say, or maybe you can say like then the thing is now nothing is more secure. Every time new technologies come, new exploits come over there, new things to bypasses are over there, right? So every time we have to be up to date. So that's what the cryptography is there in the digital age. So in this age, like if you say, cryptography is the practice of secure communication from adversaries. It dates back from ancient civilization and remain in the crucial in the digital age. Okay. So the next topic, what is encryption? We learn about cryptography. We learn about the few techniques of cryptographies, right? Now, what is encryption?
When data is converted into bits or bytes, it is a secret coded message. The file is in a secret coded message. So when you it's in you can it's original text one.
Converting this plain text into the required ciphertext.
Okay. Okay. Encryption is nothing but the process of converting the plain text into ciphertext with secret keys. Simple. Yes. Simple. Please. Okay. Before we proceed ahead, can anyone tell me what is different between encryption and encoding? Are they same?
No.
Are encryption and encoding are same?
No.
Why and how?
Right up to for that.
Any example like why and how? At least I guess there is. Or maybe not.
You have to decode it.
You can support yourself with the example you know. Why encoding and encryption are different? And if they are same, then why? Sorry. Can you speak?
And text are like really identical, like they can be decoded.
So as the
Also like if they are like wrong text, so they are like answers.
okay. Anything else?
And electric data are more secure. Including you can decode any message very easily.
That's also correct. Come on, like everybody says, encryption and encoding are not safe. Support your answer. Justify it. Okay. When we talk about the encoding, there is no something as such we say direct public key or something like secret key as you said. Correct? It's just like we consider it we write H as H. And every time we're gonna follow the same pattern. Correct? Here we are going over this is a kind of pseudo cipher, but this is also kind of encoding. Correct? But while I'm talking about the encryption, this is something where we hold the key. If my key is something 125912928. So until unless you guess the key or you crack the key, you can't decrypt my message. But then in case of encoding and decoding, you can like if you observe few of the patterns, few of the encoded and decoded words, you can easily guess that yeah, what's happening over here is like I'm passing A, it's gonna print B. Right? So that's the basic difference between encoding, decoding, and encryption, decryption, but they are not the same. They are completely different, right? Okay. When we talk about encryptions, there are different type of encryptions algorithms, encryption types also, as we see in the cryptography also. So any guess what are the type of encryptions? It's the same like cryptography. As cryptography has two types, right? Or there are two types, so there are many types. Symmetric key cryptography, asymmetric key cryptography, right? Similarly, for the encryption also, there are a few types like encryption, symmetric key encryptions as well as asymmetric key encryptions, right? When we talk about symmetric key encryptions, here what written over there, you can read like it's nothing but when we use the same key for and for encrypting as well as for decrypting, you can relate it with the lock where we use the same key for locking as well as for unlocking it, right? Okay, but how does symmetric key works? How actually symmetric key works? So it works something like this. And what we do, we take a plain text, any of the plain text, we're gonna encrypt it with the help of a secret key. Correct? We get the ciphertext, which is random anything. If you read the ciphertext, you're saying what nonsense it is. I can understand. Until you have the secret key, you can't decode it, and you will never know how serious or sensitive information present over there. It can be your own passwords. So using the secret key, same secret key with like the secret key for encryption and secret key for decryption are the same, so that we can decrypt the ciphertext with the plain text will enter over there. So this is the architecture, like how symmetric key works. Huh. Examples of symmetric key encryptions. When we talk about the symmetric key encryptions, there are three examples which have been used widely, like AES. Have you already heard about AES, TES, if I'm not wrong? Maybe you don't know the meaning, but you have heard, right?
Yes, yes.
All right. What is the AES? It's been secured using AES algorithm, the AES encryption, TES and blowfish. I guess blowfish you have heard about. No. What blowfish is? Okay, can you give an example? Oh, so the thing is, the DES algorithm was used previously, like in the early stage of 19th or 20th century, 1980s or something like that. We were using the DES for all of the stuff. But after that, we came to know that DES is not so secure. It can be cracked with or like supercomputers easily. So we upgraded ourselves with AES, where right now most of the technology are using AES for encryption, for compliance, as well as according to government norms also is one of the standard encrypting algorithm. Okay. When we talk about the blowfish, so it is one of the most famous encryption algorithm over there because it supports plain text as well as data as well as key from 32 bits, 32 bits to I guess 256 bits. Yeah. In short, we can have the plain text and the secret key of from 4 letters to 30 to line 126. Okay, 32 letters is 256 bits. 8 bits equals to 1 byte, 1 byte equals to 1 letter. Right? Everybody know now? Yes. If you write a letter A, it's gonna be 8 bits and 1 byte. Right? Blowfish supports from 32 bits to 256 bits. In short, it supports from 4 letters character to 32 letter character. Okay. Why we use symmetric key encryptions? So after considering the asymmetric key, also we're gonna like distinguish between both. Why we use symmetric key instead of asymmetric keys. So for now, you can consider that symmetric key is used for ensuring that data transmitting over is secure. Okay. Just consider SSL certificate. Like it's gonna be like again in your further slides, but still consider SSL certificate, which is something like similar to symmetric key, public key and private key. Ha. Okay. So in symmetric key, not as okay, we can consider different examples. So let's say there is a one single key, and me and my partner both are talking to each other. Okay. So every time there can be two cases. Either we both hold the same key, so that I can just type the word, I can encrypt it, I can pass to him. He can decrypt it with the same key. Okay. Or either what I have to do, I have to like write the encrypt the code using key and have to pass the data as well as key to him so that he can decrypt it and read it. So there is a chance that in between while I'm transmitting the data, my key can be stolen. Right? Key can be intercepted. There's a chance like the key is known by me and my partner both. So maybe I'm also vulnerable, he can be almost also vulnerable. The chances, the risk is more over here. Okay. But what are the advantages of symmetric key? Is like symmetric key is fast. You don't have to manage two different keys. You have one key, one data, you just encrypt it, done. It is fast, it is efficient and ideal for secure data transfer. Okay. But what are the disadvantage? Disadvantage is like as it is only single key. So if either I lost my key or either he lost his key, any which way data gonna be like leaked, right? The risk is more. And also the distribution of the key is a major challenge because either we both have to hold the key or either we have to pass the key every time you transmit the information. Now, come to the point of asymmetric key encryptions. What we learn on asymmetric encryption is that asymmetric encryption, they require two keys, right? So let's take an example. Similar example. We have two people over there, A and B. Okay. So if A want to send, not A, let's say me and my friend, I want to send data to my friend. What I will do, I will write the data, I will write a text. Okay. I will encrypt this text with the public key of that person. I will come to the point what is public key and private key. Just consider right now. I just encrypt the data with the public key of that person and pass it to him on the internet. Okay. The access to decrypted key and encrypted data. Okay. The access to decrypted data is only to that person B who holds the private key. So thing is, what happened here is, okay, before that, do you know the basic of public key and private keys? Every time we used to exchange of public keys and all this stuff. Yes or no? No. Cool. Cool. Okay, so we're gonna talk about that in the further slides in the digital certificate. Right now, just understand about asymmetric key encryptions. So for asymmetric key encryption, the architecture is something like this, where we used to like encrypt the data with one key, it is public key, and we used to decrypt the data with the help of private key. So everybody, let's say in this class, everybody holds my public key, but only I owns my private key, right? Nobody else owns my private key. So any of you can use my public key to encrypt the data, but only I holds my private key. So only I can decrypt the data which is encrypted using my public key. Got the point? Got the point? Perfect. When you're talking about the examples of asymmetric key, there is a famous example, RSA. I guess you've heard about RSA. No. Okay. So RSA is one of the most widely used asymmetric key algorithm, which is like used to encrypt and decrypt the process. So in the practical session also right now, we are going to generate the public key and private key using the RSA as well as using AES also. Okay, so that's gonna be in the hands-on lab. But the uses of asymmetric key encryptions and algorithms. Why we use asymmetric keys is to make sure that our data transmit over the internet in a secure manner. It's just like the same we used to repeat every time. It's gonna be the secure manner. It's gonna be the most we are concerned about the privacy. Like all of the points you know, it's gonna be the same. But while you talk about the advantage of using asymmetric key. So in this case, it provides us the more secure way for exchanging the information. Okay. And it uses the two keys, that is public key and private, for encryption and decryption the data. Yeah. And it is used widely for online transaction and secure communication. Whereas symmetric key were used. Symmetric key कहाँ पे use हो रहा था? AES is the example of a symmetric key, right? हम लोग symmetric key use कर रहे थे for ensuring only secure transfer of data. For ensuring the secure transfer of data only, right? In the case of asymmetric key, we use asymmetric key for online transactions, for authenticity, right? For different other factors also. Okay. Now back to the point. Now, what is the disadvantage of this asymmetric key? It is slower than symmetric encryption. Why? Because it is the two key, right? You have to first get the public key. You have to encrypt it and pass it. Then the owner of that public key uses on private key, so he can decrypt it. Then he get to know the information, right? So in this case, there's a large use process. In the case of symmetric key, it was pretty simple. I have the key, I encrypted it, I pass the data as well as key. The person got the key, person got the data, he encrypted it, done. Right? That's why it is more complex than symmetric encryption. It required more computation intensive, and here key distribution is complex and insecure because we have to first see how it happened. Is like, let's say there are two persons. Okay, there is two persons. Let's say me and someone else. What's your name? Dhruvesh. Dhruvesh. Let's say Dhruvesh. So if I want to make the communication with him using asymmetric encryption, what I will do? I will first request Dhruvesh for his public key. When Dhruvesh has public key, you're gonna give me his public key. Okay. What I will do? I will encrypt the information using his public key. Okay. After encrypting it, I'm gonna pass it as encrypted text. Okay. I'm gonna refer this term as encrypted text. I will pass this encrypted text to the Dhruvesh. Okay. Let's say in between, any of you got the same. Okay. Let's say for example, I will pass this encrypted key text to all of you. Okay. But none of you can decrypt it because it has been encrypted using the public key of Dhruvesh. So it will decrypt only with the private key of Dhruvesh. Right? So what Dhruvesh will do, he will decrypt the data with his own private key. So and we just communication, like we can start communication because we had ensured that the data over between is secure manner. Every time I have to transfer my data, I will encrypt in the public key of Dhruvesh. He's gonna decrypt it with his private key, and in this manner, communication will go and go on. But in the case of symmetric key, what we will do, that for example, what I will, we both hold the same symmetric keys. I will just encrypt the data, pass he will decrypt the data, done. He will encrypt data, pass me, I will decrypt data, done. Got my point? Okay. Now hash functions. What are the hash functions? What are the hash functions? Ever heard or seen somewhere? Any type of hash function we know. In a chain. Correct. So what actually hash function is? Actually, the hash function is nothing but is the algorithm which we use to like convert or
Capture.
we're talking about CTF right now. I know CTF is going on. So in the hash function, what we do, we use the mathematical algorithms to transform our data into some unique keywords, you can say, unique codes, so that वो unique codes से हम verify कर सकते हैं और digital fingerprints or you can say identity, correct? हम लोग hash functions क्यों use करते हैं? So here the hash functions are like lock that secure the data. They use mathematical algorithms to convert it into fixed code size or hash, so that only collecting can unlock it. You know what? Can you decrypt the hashes? Can you decrypt the hash? Let's say, for example, I have a text. I have encrypted into SHA-256. Okay, I given you the hash key, not the key. I give you that hash text over there. That I have encrypted. Can you decrypt it? Can you decrypt the hash? You have another text. You know?
We just have the text.
Yeah. No. Can you decrypt the secret key or a symmetric symmetrical encryptions?
Yeah, secret key.
If you don't have secret key. You guys are from cybersecurity, right? You have heard about various attacks, if I'm not wrong. You have heard about various attacks, right? What did I perform for like decrypting the passwords or like for decrypting the hash values? Good question, one of them. Any other tool you know? Man in the middle. Man in the middle. Man in the middle attack. Yeah, it can be used to like capture the secret key if it is like transferring between two persons. That can be in one use case. What are tools you can use to decrypt the passwords which are encrypted in SHA or MD5 or using any different algorithms? Hashcat. John Veriper. Have you used them? Yeah.
Yes.
Okay, you are successful. You were successful then. Like, have you like decrypted the data?
Actually, they are like very much intensive. And laptop being supported and give up.
Your laptop you can pressure cooker. Actually, correct. While the thing is now we can decrypt the data, we can decrypt the passwords which are stored in the database leaks. So whenever the database leak, we like the thing is now we get to know about various data leaks, where we get to know the password of the user using the also with the along with their email address and phone numbers. But in order to get the password plain text, we have to decrypt it, right? So for decryption, it required a lot of computation power. When I say a lot, it means a lot, like very much. So the time required to decrypt the password is proportional to the computation power you have. Either you are trying brute force or any different method, you are trying dictionary or any other. It totally depends upon how many computation power you have. How is, let's say, if you have 1 GB RAM, not 1 GB, let's say you have some basic computer with 4 GB RAM and all, right? So if you are trying for brute force, it's gonna you have at the speed of I guess some 15 to 20 words. I'm not wrong if right. Something about 15 to 20 passwords a second you're gonna try for some computer, basic computer with a 4 GB RAM. But if you have supercomputers, you can say, with heavy CPU, 16 to 32 GB of RAMs. You can hold them on. You can actually take such CPU with the specific specifications on cloud. You can take such like instances on the cloud using such as specifications like 32 GB RAM and all. And if you perform a brute force from such computers, the password rate gonna be like somewhat about 500 to 1000, correct? But it's gonna charge you more. So totally depend upon the computation power. There are various tools available in the market to decrypt the passwords, like John the Ripper, Hashcats. Even we decrypt the passwords of Wi-Fi. When we capture the handshake of Wi-Fi, okay, then that's a TCP or TCP handshake. I'm talking about the handshake between the Wi-Fi. Have you tried the Wi-Fi hacking?
Yes.
Which method? Which method actually? WBSP using Wi-Fi. WBSP attack now. Have you tried like password handshaking methods where you capture the handshake? First we used to like authenticate the user. Then we used to capture the handshake when the user tried to connect. Then we get the hash of the password.
Like list of passwords.
No. Let me just explain you that part also. So how the Wi-Fi hacking actually happens is like there are two ways. First is WPS. If WPS is enabled in the Wi-Fi, then you can try WPS pin attack. Okay, you capture the WPS pin. You try that bully attack if I'm not wrong. Which gonna crack the WPS pin into your PSK passwords. That's the one method. The second method, which is most famous, is handshake one. In which what we do, first we send the authenticate packets to the router. So it's gonna like disconnect the user from the Wi-Fi. Okay, if let's say my computer is there, it is connected to the Wi-Fi. I will send the authentication packet to the router. It will disconnect my laptop from the Wi-Fi. Okay, then I will listen like what the packet is transmitting. When my computer will retry to connect in the password, I will capture the packets on the handshaking happen between the router and the computer. I will capture the packets over there. In that packets, there will be passwords. So if I will decrypt that packets, I will get to know what are the passwords over there, what are the passwords of Wi-Fi. Okay. So that's also not too simple in that case. Also totally depend upon how secure the passwords are. But the thing what I was trying to say is like we can decrypt the passwords. We can decrypt the hash functions at certain limits. It is not guaranteed you can decrypt the password, you can decrypt the hash functions every time. Maybe you are lucky if you got decrypted. Okay. Now, how hash functions works? Mostly we use hash functions like not to transmit the data in a secure manner. We use hash functions for different purpose. We use hash functions to like ensure the integrity, to store the passwords, to store the data in encrypted format, right? So as we talk about symmetric, asymmetric, a hash function is something different, which is like have different purpose, which has been designed in different meaning. So in the hash functions, sorry. The hash function encrypt the data and store it securely without revealing the original input. That is without revealing the or plain text. And they are used for the password storage, data integrity checks and all. What are the different types of hash functions? There are different type of hash functions like MD5, SHA-1, SHA-256, SHA-512, if I'm not wrong, right? Okay. Hash functions, as I said, it is always used for the purpose like it's used for password storage, for digital signatures, for data integrity check. It's like our data has been intercepted in between or not. Correct? The advantage of hash functions like it used to convert our data into fixed hash size value. As you said, if we use the base 64, we can easily identify that it is base 64 or it is 75 by just looking at the hash, because we know every time we use base 64, it's gonna be the same length, or it will initiate or end with the something like same format, right? Similarly, we can identify whether the hash is 75 or hash is sharp. Okay. Now, the disadvantages for using hash function is first, it is irreversible. When I say irreversible, what it means? What do you mean by irreversible? Once you encrypt it, you can't encrypt it. Correct? But in the case of base 54, you used to decrypt it, right? How? The thing is, it also depends upon different use cases. In the base 64 also, there are various hashes which you can't decode using any other decryptor. Even you use any base 64 decoder online or use download any other tool in the Linux, still you can't decode it, right? So it's also depend on the one use cases. So the disadvantage over here is like you can't reverse it back to the original text. And apart of them, they are vulnerable for collision attack. What do you mean by collision attack? Is like it use the mathematical computation algorithm, right? So let's say when I say hello, it's gonna generate some hash. I'm gonna repeat some different, let's say any random word. I'm gonna say world. So maybe possible the same hash value can be repeated. So it totally depend upon which hash function it is. Whether it's amplify or SHA. In SHA, it's not gonna happen that वो repeat होगा. But sometimes it happens in the base or base 64. Sometimes, not always. It's 2 or 3%. When the hash value gonna repeat itself. That is this vulnerability is called as collision attack. Okay. So if the two hash values, the hash values are same of two different plain text, so it is not correct manner, right? Every time तो like उसका अलग होना चाहिए था, इसका अलग होना चाहिए, but दोनों same है. So there is something like कुछ तो गड़बड़ है, kind of. While we compare the encryption algorithms, okay, so back to the point. Right now, in the encryptions, we had covered symmetric encryption, asymmetric encryption, as well as hash functions. Okay, so can you just distinguish between that? 1 point from symmetric, asymmetric, hash. On same key, a point that symmetric key is this single key. What is asymmetric key is this? Public key and private key. That's two different keys. A hash function is this. Irreversible. They don't give us the key. Right? Okay. Okay. Asymmetric key uses for secure data transfer. That is asymmetric key is for what? Online transactions. Authenticity. Where hash function is used. You don't have to decode it. Not bad. For password storage, for data integrity. Correct? Even now also, if you like go and download any source, let's say you, any of you have downloaded the Linux for dual boot or for live, download it. Just have that. While you download the Linux, they also give you the hash key over there. I can show you. Okay. So do we have to bypass the firewall also? So maybe firewall is blocking other. Cool. I guess firewall is blocking side too. But still, like if you have downloaded the Linux also, every time you download the Linux ISO file or any of the files, you also get the hash keys. You can verify the hash key that the ISO file you are downloading is the same ISO file they have uploaded over there. It is not malicious or none of the threat actors have downloaded it and like modified it according to that. Okay. Fine. Next, we're gonna cover digital signatures. Just a short summary. Till now, what we have covered. We had covered about cryptography. We talked about cryptography, types of cryptography. There is symmetric key cryptography and asymmetric key cryptography. We talked about few of the techniques like ciphers and all, right? We have talked about encryptions, type of encryptions like symmetric encryption, asymmetric encryption, hash functions. All right. Any question from these other topics? Any question? Any query? Any doubt? No? Okay. We can proceed with the next topic, that is digital signatures. So what are the digital signatures? What are signatures? What are the signatures? What are the signatures?
It is the identification person. It is
You guys you don't have the checks, right? To like sign it. But still, what are the signatures? You have seen, na?
It is a key for various purposes. Like if you write in a check, you can grant it.
How you can define the signature as?
What is that? Unique.
Maybe your signature also the same of any other person. Maybe not in your college, maybe from different college. Can be same possible. Possible. So it's not the unique first of it. Okay, then we will get. So what is a signature? Every time you used to sign in a form, in a consent, right? What it shows? Authentication. Okay. Okay. So signature is nothing but it is you can say a way to like show the authenticity that the person who is representing himself is the same. Correct? If I am saying myself Ashutosh, what's the proof I am Ashutosh? You can verify my signatures, you can verify my digital fingerprints, right? Right?
Yeah.
So when you talk about digital signatures, what it means? Like physically you can like observe ki, your face is like similar or not, your fingerprints are similar or not, your Ashutosh or not, your real or fake. But in digital world, we have to also verify that the user is same or not. Either someone else is if you're getting the same person, or like what's happening over there. So for that also, we have to verify the users. And for that, we used to use digital signatures. Okay. So digital signatures is nothing but digital signatures is nothing but it uses the encryption technology to verify the authenticity and integrity of the documents that ensure that the document has not been tampered and it come with the handling online transaction, legal documents, and sensitive data. That will be. How many all have Demat accounts? Any of you have Demat account? Any of you do trading?
Parents do. Sorry.
Parents do. You don't have your own Demat account. You have your own Demat account. You have. On which application you are using trading? Grow. Yes. Oh, opening a Demat account. What are the procedure you do? Like either you go to the bank with the proof papers, or you did it online.
PAN card.
File card or sign in on the PAN card. PAN card they give Aadhaar card and PAN card to the bank.
You go to bank or you do it online? Online. You go to bank.
First, when I went to open the account.
Or not account, I'm talking about demat account. Your saving account is something different. No? Actually, so for that, for demat account also you went to the bank only.
Yeah.
But we are not same. We are not same Zero. We did it online using the application on the Zero. As a Zero the applications. So for opening a demat account, what we did is like we go there, we verify our we verify our we verify our authenticity over there by providing Aadhaar cards, verifying the Aadhaar cards, verifying the PAN cards, right? Your digital signatures also, correct? Photo, you have uploaded your photos for the consent. Okay. While verifying the Aadhaar card, what we do is like we used to enter our Aadhaar numbers, our phone numbers, we used to enter our OTPs. Okay. So what it shows like, yeah, I am the person who own this Aadhaar card. Yeah, I am the person who own this PAN card, and I am giving the consent to open my demat account. Correct? Correct. So in the same manner, what we do is like we can tell this like we are proving our authenticity over there. We are proving our identity over there. We are the person we are showing there. If I am opening account in the name of Ashutosh Upadhyay, so I have to submit the documents. I have to verify that yeah, I am Ashutosh Upadhyay, I am not someone else. Correct? For that also you have done your digital signatures in the bank, in the PAN card, you verify Aadhaar card. Aadhaar card gonna send your TPs to the demat then CDSL. Okay. Also, you have sign over there on the screen also. You have signatures over there, right? So you're proving your authenticity. Similarly, when we talk about the digital signatures, it is nothing but it's gonna show your identity. It's gonna verify your authenticity using the various encryption methods. Okay, how it works? You're gonna see how digital signature works. So when you talk about digital signature, we are secure enough. But that should be a point, not that a unique point that everybody holds. For physical identity, we hold the Aadhaar card. Everybody have the unique Aadhaar card. But what about the digital? Everybody owns their own private key, right? Yes. Everybody owns their own private key. We never share our private key with anyone, correct? So we can consider private key as a unique identity. With the help of that private key and public key, we can use this encryption method that is called an asymmetric encryption. Correct? Asymmetric encryption has the private key and public key, right? So the digital signature we are talking about is also a type of asymmetric encryptions. Here, what happens is like digital signature are secure, electronic signatures that verify the authenticity of documents. They use the encryption technology to ensure the integrity of the signatures and all. Okay. In short, what actually happens is like while we are opening a website, let's say I'm opening Google.com. Google.com has its own SSL certificate. That SSL certificate, that is the digital certificate of the Google, which shows us that yeah, this website is a legitimate website of Google.com, and here is the authenticity certificate over there. That is the SSL certificate. Okay. So when we talk about the SSL certificate, that is nothing but that digital certificate which can be created using digital signatures. Correct? There, the private key used to create a certificate, it belongs to Google, and we can't see that private key, but yeah, we can see the public keys over there. Even you guys can see, you can open the Chrome, you can go to another website. You can click on that lock icon on the side of URL. You can click on view certificates. You can go to show certificate. There you can see the public keys. You can see the date of expiry and all. So like that's something. Okay. When we talk about the example of digital signatures. So the digital signature and digital certificate are two different things. Okay. Digital signature is something which used to verify authenticity. Because certificate is something which shows ki like, yeah, what is this person is identity signatures. So we can create a certificate using the real signatures. You can sign the certificate. I mean, at the end you wanna use, you can show the certificate like, yeah, it's my certificate. It includes all my data. What the certificate includes, include your name, include your country, your state, organization name, CNAME, and this all data have been verified with CA, that is certificate authority, the third party authority. We are talking about that in the further slides. For now, what's that's the example of real signature in commerce. So when we real signature provide a secure way for signing document electronically, including online purchase. They are the authenticity of the signer ensure the integrity of the documents. That's nothing but opening that demat account as said. In the same example, you can relate with, right? Use case of digital signatures in government documents. So, charging. When we talk about the government documents also, we can verify using Aadhaar cards, using PAN cards and all. So these all are the like theoretical part you can consider. The benefit of using digital signatures. So benefit is the same. Here we have to verify the authenticity. We have to verify the authenticity of electronic documents. Like for example, wait. They use public key cryptography to ensure security and integrity. You know what public key cryptography is? Don't say no. I told you. What is public key cryptography?
Symmetric.
Asymmetric.
So you can give the public.
Okay. So the digital signatures also uses the public key cryptography to ensure the security and integrity. They can be used for legal, finance, business transactions and all to reduce the cost, to reduce the time to go to the bank and open a demat account. You can done it online by verifying the digital signatures online. Correct. So they can help you in the various means. So while talking about the digital signatures, they are actually very beneficial, and we are going to make one of the digital signatures over here. But what is the potential challenge and limitation while we talk about digital signatures? See, nothing comes here without the challenge. Nothing comes here without the risk. Correct. So in this case of digital signature, what are challenges and risk? Any of you? Any use case? How a digital signature can fail?
You make a mistake while doing the sign.
Human error. Both. Technical error. Maybe your college Wi-Fi is blocked off server.
Yeah.
And you try to verify, but you can't open. Correct? Correct. So there can be multiple use cases. Okay. So we have to consider the limitations, the challenges according to various scenarios that can be differ from condition to condition. Either it can be happening due to technical errors that you're browsing the internet mode or something like a server is not working properly or load on the server is more, so it can't verify your digital signature on time. Timeout gonna be happen, right? So it totally depend upon different scenarios, different conditions. But yeah, there are also potential challenges and limitations in here also. As mentioned, digital signature of authenticity and non-repudiation, still they are subject to for technical failure, legal challenges and human error. When I say legal challenges, it also means like for every time we verify our data, there are some compliances like what data they can take and how they gonna store them, right? In the case of stock markets, in this case of like that finance related firms, they then mandatory that the compliance should be there that the data they are gathering should be stored in the proper encrypted format, and the data that they are storing it should be proper audited infrastructure where the infrastructure was that PCs or the person who are involving in this all data capturing and storing their laptops and all the stuff, like all of the things that are involved in the building should be audited properly by the authorized firm. So that's a different compliance matter. We're talking about the compliance. Apart of that, we discussed the human errors, we discussed the technical errors. Now come to the point PKI. What is PKI? You all have computers on the globe. Search what is PKI. Okay, so PKI is nothing but public key infrastructure, right? Now, what is public key? You talk about the later. What is public key? See, the public key and private key both are used in encryption. They are not encryption, they are used in encryption, right? Where public key is accessible to everybody, right? It is accessible to everybody. It can be used for encrypting the data, but it is not used for decrypting it. For decryption, we always use private key, correct? When we talk about public key infrastructure, what it means is this. When we talk about public key infrastructure, it is made up of CA, that is certificate authority, the authority which signs your public key as well as your private key. It is made up of registration authority, which verifies all the data. It's made up of your digital certificates and your certificates revocation list. Okay. What are these all terms? CA certificates. You heard about CA certificate? The security guy. Have you heard about CA certificate? Have you configured your burp suite to the browser? Have you? No. Never? No. Yes. Yeah, it's the first thing you should do while doing security. While you are using burp suite, when you are configuring your browser to the burp suite, what you have to do, you have to take the CA certificate of the burp suite and submit it to the browser so that every data transmission from the browser can be intercepted from the burp suite. So that you can perform MITM, you can perform the man in the middle. Okay. Okay. For those who don't know about this all, I will make it simple. Thing is, for now, understand that PKI is nothing but it consists of the infrastructures which involves CA, so it is certificate authority, not that CA finance or different CA, and registration authority, which approve your registration for certificates, your digital certificates, and your certificate revocation lists. Okay, what are these terms? So, the CA, the certificate authority, it issues the digital certificate. So every time I have to issue a new digital certificate, I have to send the certificate request to my CA, to my certificate authority. And what CA gonna do? They're gonna approve when CA will approve my certificate, it will cross verify the data I have entered in the request. And if we approve, then only I will get my certificate. In this case, let's take the example of SSL. You know how self-signed SSL are made? Any of you have made your self-signed SSL certificate? No? Okay. So for making your self-signed SSL certificate, there are few steps. Like first you have to create your public key and private key. That's the very first thing. Okay. After creating your public key and private key, you have to create your certificate, your digital certificate, normal, using your private key. Okay. When you on your digital certificate, you can pass it and create your request, that is CSR, that is certificate request, in which it includes your name, your details like your name, your country, and your state, A part of that, it includes your like C name. That is the name of the domain name for which you are applying for the SSL certificate. Let's say if I have the website called ashutosh.upadhyay.tech and I want to implement SSL certificate over there, what I will do? I will pass my the CA name as ashutosh.upadhyay.tech. Okay. For after that, I have to provide my email addresses and a few other informations. Whenever I is like generating a CSR file, that is a request file, I have to pass this all information in that. And once the CSR file is ready, I have to submit this CSR file to CA. That is my certificate authority. The certificate authority is a third-party authority which owns the like access to generate SSL certificate, to sign it, and also to revoke it, like to take the authority from the SSL also, so that your SSL gonna be waste. Okay. So they owns the authority to make your SSL valid or invalid. Okay. So when my CSR file is ready, I will submit that CSR file to CA, that is my certificate authority, and once he will cross verify all the details, he will approve. Then I will get my SSL certificate, which I can like view on my website. And you the one on the website is ashutosh.upadhyay.tech. Correct? Okay. This is the simplest term. Okay. Now let's get to the point. What are the digital certificates? It's 3:30. You guys need break? Yes. Yes, need break? Okay. 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 After the break, what we are going to cover, just a short glimpse. We are going to cover this all, then hands-on lab. वो सारा नहीं है, वो मजेदार है बल्कि. Till now we had covered the theoretical part. After the break, there's a little bit of theoretical. Then we are going to the practical one. We are going to make real CA certificates, not CA certificates. We are going to make SSL certificates. We are going to provide this SSL certificate to our local host. Local host हमारा HTTP भी चलता है, हम उसको HTTPS पे चलाएंगे. Okay. Then हम वेब सिक्योरिटी पे जाएंगे. वेब सिक्योरिटी में हम बात करेंगे. We are going to talk about various vulnerabilities over there. Maybe this time we are taking the port signal labs for now. Okay, because this is introduction. After that, maybe in further sessions, you got to know more about web security. So for now, you guys can have 10 minutes of break. Okay. Any question? No? So connect my laptop to this also. Turning on your mic. Should we start? We have now 5 minutes left, and we have to cover a lot. Start. Okay. We have covered this part, I guess. We had covered this. Yes. We are on this CA. What is a registry authority? Just read it out. It's quite very simple. So when we send the request for certificate to CA, it actually the array which verify the data. We have mentioned the request, right? Then we have certificate repository. All it is a collection of you can see database. A large number of certificates are stored. You can even check the certificates of various websites from the link website called as crt.sh. cert.sh. When go to the Chrome, if you want to try, just enter cert.sh, crt.sh. Interface will be open. I can just show you. Let's see here. From cert.sh, you can search for any other domain. Let's say I will search for what is it? Help me with the spellings. Say Shanangle.com. Okay. Yes. Cool. So for shanangle.com, the issuer name and issuer details are given over here. And this CA certificate, the SL certificate has been used on this domain as well as on health.shanangle.com. Okay. So I guess the name health, it's gonna show that whether the website is healthy or not. Okay. From the next point, certificate revocation list. What it is? So it is nothing but to schedule the expiration date. Like, let's say I issued a CA certificate. I issued a legal certificate to a website, anonymous website.com, something. And if I'm performing any illegal things over there, so the CA has the right to revoke the validity, to revoke the HCA authority, like authority from that certificate before its expiry. The thing is, whenever we apply for the SSN certificate, they get the validity for 1 year. Maybe for 1 year, maybe for 2 years. It will depend upon how we are like asking or how we are issuing it. We are requesting for, right? But the CA also holds the right to revoke the rights from the CA certificate. So that's it comes under revocation list. That's under digital certificates. Okay, so till now we discussed about the PKI and what we had covered right now, that is CA, RA, certificate repository, CRL. These are the components of that PKI. But when we talk specifically regarding the digital certificate, that is nothing but this also same, like where we have to verify the securities data, identity of the users, devices, websites on the internet. So to verify that whether the website we are visiting is authentic or not, is the actual website or not, either it is fake or it is phishing website or something. So we can check using the certificate associated with the websites. Next, when we talk about digital certificate, there are a few types of digital certificate like SSL TLS certificates, even code signing certificates for software securities. Also, there are email certificate for encrypted email connections, communication. So whenever we are using email using SMTP servers, we also provide a layer of additional security by providing a email certificates, which shows that the email address or the SMTP server we are using is legitimate, not the fake one. Now, how the CA certificate works? CA certificate verifies the identity of the website person organization. They works by using public key encryption to secure the online communication. Similar ways, when we talk about real certificate, it also being used encrypted using the help of public key. So if you want to verify the user, so that the thing is when if you want to see the actual data behind the CA certificate, you need the private key which is owned by the owner. So the encryption behind the certificate, the SSL certificate is the public key only, right? Importance of certificate revocation. So when we talk about importance of revocation is like to maintain the trust and security on the internet. So for example, when you talk about the phishing sites, it is a very myth. Like if okay fine. When you talk about the phishing site, is the myth that phishing sites only works upon HTTP. They can also be on HTTPS. Right? I can hold a domain called ticket-irctc.com, where I can host a fake website of IRCTC, where people can come and try to purchase the tickets. But I am the owner of the domain. I can host anything I want. So let's say I just purchased a domain. I purchased the SSL certificate also for that. I apply certificate also there, so that whenever you can try to connect to that domain, it should go on HTTPS, not HTTP. Okay, so I can gain the trust of the user. Our service legitimate. Okay, but when you're talking about the content of the website, it may differ. I can post there some malicious content. I can post a fake website so that whenever you try to purchase the ticket, the mission will complete, but you won't get the ticket because I get the money. I will send it. That's the case. Okay. So in this case also, if you report regarding the website, the CA has the authority to revoke the access, to revoke the rights and authority from the SSL. So that's why the revocation also matters a lot to like maintain this trust. And we're talking about the conclusion. So digital certificates are used to verify the website's identity, to establish the secure channel, so that data can be transmitted in a secure way, and to maintain the integrity also. Okay. Also to keep up your certificate up to date and securely protect your online presence. So I guess recently on a Hotstar, they haven't updated the SSL certificate, it got expired. While people are watching the match, suddenly their like HTTP connection got back to HTTP, and lots of the users are getting they got disconnected from the Hotstar just because of the mistake, because they have not updated up to date their SSL certificate. So while we are maintaining our websites to maintain the trust, we should also take care of the dates. Like if I have the validity up to 1 year, so after 1 year, it's gonna be invalid, and once it got invalid, all the channels are going to be in unencrypted format. So it can be like clear text format where no data can be encrypted, and everything you are like transmitting can be seen by any of the person who is eavesdropping or like capturing of packets. Maybe by your okay. Now hands-on lab. So while taking the lab, let me share my screen. Cool. Turn the screen off from here. Thing is, I was using Linux, but there was some issue. I guess I can't connect to the Meet. Also, I can't even share the screen with this website what we're using. I guess Microsoft Teams. So I can't share my screen in the Teams as well. Even there was an issue by like sharing the screen also using HDMI. So what we are doing, I'm just sharing a screen from Windows so that you can just see what happening over there. And for the sake of tools and all, I am using WSL on Ubuntu in my Windows. So I have the access of WSL. Yeah. Cool. So in your PC, is OpenSSL installed, or you can just install OpenSSL if you want. Like how many of you have their own laptop right now? How many of you have your own laptop right now? Okay. And how many of you have Linux installed in that? One to challenge. Any other Linux distro? Maybe in virtual machine or anything. No. If you have Linux installed in your laptop, you can use it. It will be more easier for you to like install the tools OpenSSL. Or if you are in Windows, you can look how to install OpenSSL on Windows and just install the binary for OpenSSL in your Windows also. I repeat the name OpenSSL. If you have Linux, you can open your Linux. You have 2 minutes to set up. If you have Linux, boot up your Linux. If you have Windows, please download OpenSSL binary in the Windows. Let me know once you are all are ready. Open SSL. Even if your Windows WSL is there, you can put it out. Or else I can show you a short trick. Fine, you can use it. You can go to your site console.cloud.google.com. Console.cloud.google.com. Go to the site, log in. They provide a free Linux terminal to use in 15 to 20 GB of storage and high bandwidth and like some about 1 to 2 GB of RAM also. So it's free for all. You can use that Linux shell also there. Once you logged in, there in your top right corner there's a icon for terminal. You can click on it over here, and you will get a terminal open. You have two options. First, if you have Linux, boot up your Linux. Either you can try to download OpenSSL in your Windows, or either you can visit these websites, console.cloud.google.com, log in, open this terminal. Done? Everybody done? Say yes or no.
Yes.
Yes. All right. So first thing we are going to do is we are going to generate a private key for us using OpenSSL. You can verify either OpenSSL is installed or not by entering OpenSSL in a terminal. OpenSSL. And okay, it's visible now. Great. As OpenSSL is installed, it's gonna show you this, or else it will give you an error. Correct? Okay. First, we are going to generate a private key. So for that, for OpenSSL also, you can check the manual for it. Here is the manual for OpenSSL where you can generate various of the hashes, or you can generate various keys using various different algorithms which OpenSSL supports, like AES, RSA, or SHA, MD5. OpenSSL support this all. And apart from that, also there are various different algorithms which OpenSSL support, and it's inbuilt in it. So for generating, okay, all on the same page. Raise your hands if you are like done this by this. Having any issue, you can ask me. Okay. Console.cloud.google. Just repeat. Yeah. When you open the website console.cloud.google.com, on the top right, there will be a button called as Activate Cloud Shell. Click on it. You will get the shell. Yeah. Then first of all, anybody is the shell name issue? I guess looking properly. Right. Most of us are on the same page. So for generating a private key, from OpenSSL, you have to enter the command like OpenSSL generate RSA, because I want to generate a RSA and private key, right? Then you have to specify what you're going to name the output folder. So I want to name it something like private key.m, maybe private.key, anything. And I'm gonna specify how many bits it should be. It should be like somewhat about 2048 bits. And done. Here I have the file private key. I can open this file private key. it look like something this. Right? Okay. Tell me इसका अभी तक शेल ओपन नहीं हुआ है. ये console का शेल अभी तक इसका ओपन नहीं हुआ है. Okay. बाकी सबका हो गया. सबका हो गया बाकी. Okay. So here you have to enter the command open SSL space gen RSA GEN RSA, that is generate RSA. Okay. OpenSSL space gen RSA minus out space minus out space name the file in which you want to store. I named it private.key. You can name it anything else. Maybe private.10. Okay. Name the file you want to save the output. After that, specify the bit. CR will specify 2048 and press enter. So here what we are doing, we have then okay, for you test cd test. Yeah. So I have generated this private.key file over here. Now using this private key, we are going to generate the public key also, because asymmetric encryption required both private key as well as public key. Correct? Okay. So for generating the public key, we have to enter the command openSSL openSSL RSA, where you have to specify first like what do you want to okay. Let me first specify your private key as an input. So minus input minus in that private.key. Okay. Then you have to specify what you want in the output. I want in the output public key. So public pub out. Perfect. After this, I want to save the output in a file. So I will enter minus out public.key. I repeat. Yeah, I have entered OpenSSL RSA because I am using RSA algorithm. Then I have specified the input where I am passing my private key as an input. Okay. Then I want the output to be a public key. That's why I had entered the argument minus pub out. Pub represent public key, out represent what the output gonna be. Okay, output format actually. Then I want the output to be stored in a file. That's why I have specified the argument minus out space file name. And done. Now when I check the directory, I have two files, private key and public key made up of that same private key. Correct? Everybody getting the two files?
Out like me, out space.
What?
Private generator
प्राइवेट जनरेट जब किया तो आउटपुट फाइल में स्टोर करने के लिए माइनस आउट एलएस करके तो एक प्राइवेट की आ गया. नाउ अब पब्लिक की जनरेट करने के लिए ओपनएसएसएल आरएसए माइनस IN करके इनपुट में तेरा प्राइवेट की डालना है, प्राइवेट की का नाम. ठीक है. देन माइनस PUB out, that is public key output format में चाहिए. Then minus out, where you have to specify the name of output, in which, in short, the name of the file in which you want to store the output. If I don't specify this thing, like let's say I don't specify minus out public dot key, what's gonna happen? It's gonna print the output here only. So I want to store this output in a file. That's why I have specified minus out. Okay. Now just try to make a file in which store any of your plain text. Okay, I'm gonna make a file. I'm gonna save my plain text as this is Ashutosh Upadhyay into a file name plain text.txt. Okay, so it's gonna save my output in a file called as plain text.txt. Perfect. Perfect. Good. I'm gonna encrypt it. So for encryption, I guess that's fine now. Either you can save the file using, you can touch file name, it's gonna create the file. Then you can use visual editor called as VI, or you can use Nano. Are you guys aware of this visual editor, right? Yes. Yeah, I hope so you are. So just take it. OpenSSL encrypt, where I have to specify the encryption. So I'm gonna use AES 256 CBC. I'm gonna pass the input as plain.txt and output pass negative time. I'm gonna pass file as private. Okay. And its output अगर मैं डालता हूँ cipher.txt. Okay, for this अच्छा मैंने RS से लिया था ये इसमें दिखा रहा हूँ. Perfect. Cool. RM cipher. ठीक है. OpenSSL generate key. Just a minute. Already 420, I guess. Cool. So right now, what we have here, we have our plain text. Everybody have their plain text. Yes. Their private key, their public key. Yes. Now what we need to encrypt our plain text using a public key. Correct? Okay. OpenSSL RSAUTL result. Encrypt our input as plain txt. It's in key if I'm not wrong. minus public input में डालना है minus in key, it gonna be my public key, and I want my output in ciphertext dot txt. You can see. Okay. Then now let me explain what I did. Cool. What I did over here is I entered a command OpenSSL, okay, then RSAUTL, which represents I am going to perform the actions on RSA encrypted payloads. Okay, that is the RSAUTL. Then I have entered the attribute as minus encrypt, which is gonna show I want to encrypt something. Okay. Then I passed my input as a plain text, that is minus in, which represent input, right? I passed the input as plain text. Then I enter pub in. Pub represent public key, right? So I am also passing my public key as an input. My input key is nothing but my public key, correct? And I want to store the output in ciphertext.txt. So after entering the command, I see that the new file is generated named cipher.txt, which include, when I just try to read this file, I can see this all as output. You can see here. Okay. Now for decryption also, we have something similar. For decryption, we have to first specify OpenSSL RSA alt, because we are using RSA algorithm for public key, right? So RSA alt minus decrypt, where we will pass our input as ciphertext, and should I zoom in? Are you visible over there? दिख रहा है? It is visible now?
Yes.
Perfect. Perfect.
Oh, I got it.
OpenSSL RSAUTL minus decrypt. I want to decrypt a file called as cipher.txt. So I will enter the input as cipher.txt. Then I am going to input the key, that is my input key, which is going to my private key. See what happens right here. Let's take a quick recap. Okay. If I show you the history command, whatsoever command I have written used previously. Okay. So first I have used this. Where it got? Yeah, it is. First command I have used is OpenSSL gen RSA, correct? Which generates a RSA, which generates the output using RSA algorithm, correct? I stored that output in a private.key file, correct? Here. Okay. It's visible. I'm talking about here. Here, what I did, OpenSSL RSA minus out private.key 2048. So here, what I did, मैंने OpenSSL use किया, जिसमें मैंने लिखा है generate RSA. Like I want to generate a random text using the RSA algorithm, and I want to store that output in a file named private.key. Okay. Here I mentioned I want the output to be 2048 bits. So I am specifying the length of the outputs. Okay. So what it did, after entering this, I can check using ls. I can check कि मेरा private.key जो file है वो create हो गया है. Anybody has created file? ठीक है? Then हमारे पास private key आया. हमको अभी चाहिए public key. Correct? So for public key, what I did, OpenSSL RSA. ठीक है?
उसमें मैंने इनपुट पास किया सेम प्राइवेट की, जो प्राइवेट की हमने ऑलरेडी जनरेट किया हुआ था, इसको एज अ इनपुट पास करूं, ठीक है। Then what I'm defining over here is like I want output into a public key format, that is pub out, pub out. Pub out says that it's gonna show the output into a public key format, okay, where the input will be private key, and after entering this it's gonna show me the output of public key. So I will store that public key in a public.key file. Alright, so till now I have private key and public key, two things. Now for showing the asymmetric encryption, I need four things, right? Private key, public key, and three things. That is plain text. So plain text is something, but I have stored over here. That is okay. Echo. This is Ashutosh Upadhyay into a plain text. So what it does, it's gonna say this is Ashutosh Upadhyay into plain text.txt file. So if we check in the plain text.txt file, there is a string written as this is Ashutosh Upadhyay. Correct? So this is the message I want to send someone. But I want this message to be sent in an encrypted format. So what I did, I gotta encrypt this message using our public key. Correct? So what I gonna do? Open SSL, encrypt using AES. Okay, it's for AES. So when I was trying this, encrypt using AES, it shows me the error because हमने जो private key generate किया है वो RSA algorithm से किया है और यहाँ पे encryption में AES से कर रहा था, so it shows me the error. That's why I just use this command. Okay, it's visible there. Open SSL RSA UTL. So it's gonna operate on the file which is generated using RSA algorithm. Correct. So open SSL RSA UTL minus encrypt because I want to encrypt the plain text where I defined my input file to be a plain text.txt, which includes this my plain text, the message I want to forward. Okay. I entered pub in any public key as an input where I pass my input key as public.key. Correct. And I store the output in a ciphertext.txt. If you have understanding of Linux, you are working with Linux, you're gonna easily understand all the commands written over here. Okay. So after executing this command, it's gonna generate a file called as ciphertext.txt. So if you want to check, I can show you. Here I have this file ciphertext.txt, plain text.txt, private key, and public key. Correct? I have 4 files. Now, if I want to send a cipher.txt stores the encrypted value. So I want to send the encrypted value to my friend. So I will share this cipher.txt. If you want to read what you insert the file, if you understand, please let me know what it is. So this is nothing but till here actually. It is nothing but our encrypted value, which was encrypted using the public key. Okay, so if anyhow somebody intercept or request, all they gonna get is this nonsense, you can say, correct? But when the person receives a file, okay, he gonna decrypt it. How he can decrypt it? Using the public private key, which is being used to like encrypt it, correct? So when we try, let's say, for decryption, we can use this command OpenSSL RSA UTL because RSA where I want to decrypt, I am passing the input as ciphertext.txt, which includes my encrypted value. Correct. I want to pass in key as private key. What if I will pass my public key instead of this? Is the ciphertext gonna decrypt? अगर public key pass करूँगा decryption के लिए वो decrypt होगा? No, नहीं हुआ. Instead, if I will pass my private key, it gonna show me कि जो ciphertext.txt में जो भी content है, वो decrypt होने के बाद क्या output दे रहा है? This is Ashutosh Upadhyay, which was present in the plain text. Correct? So this is how the like our private key and public key, private key and public key actually like encrypt and decrypt the files. So if I want to pass, let's say I have some different content in the plain.txt. If let's say I just make another file called as secret message.txt, in which I have written this is very sensitive file and my password is 120. I created a new file called as secret message.txt and I want कि ये जो फाइल है मैं जिसको भेज रहा हूँ सिर्फ वही एक्सेस कर पाए और कोई नहीं. सो मैं क्या करूंगा, ये फाइल को एनक्रिप्ट करूंगा वो पब्लिक की से जिसको मेरे को भेजना है उसके पब्लिक की से. ठीक है, फॉर एग्जांपल आई हैव पब्लिक की ओवर हियर, उस सामने वाले बंदे के, तो पब्लिक की हर एक का सबके पास अवेलेबल होता है. करेक्ट, वी कैन हैव पब्लिक की ऑफ एनीबॉडी but we don't have access to of private key. So if I have public key of my partner whom I want to send this message secret message.txt, so for that first I will encrypt this message. How? Open SSL RSA UTL minus encrypt. Okay, I'll pass the input as secret message.txt. Correct, I will pass my public key. Okay, it's on the new page, new line. Okay, I will also define that I am just passing a public key for that. So for that I use pubin and in key is gonna be my public key and enter. Here I haven't stored in the file. So when I will try to encrypt it, so in the secret message.txt you know what the content was there, but after encrypting it's gonna be in this format, this y and xt bracket d a f c and something. I don't understand what it is. Correct, let's store this output in a file. So I want to store it in a file name as secret encrypted, something different, let's say encrypted.txt. Here I have stored the output in an encrypted.txt. Now if I will send this encrypted.txt to someone, let's say I want to send to a partner, a part of my partner, if anyone have the access of say, this encrypted.txt, he can't get to know what was the actual text I was encrypted. So when my partner gets this file, what he will do, he will try to decrypt it using his private key. So let's do it. Open SSL RSA ULT minus decrypt. I want to decrypt a file called as encrypted.txt. I'm gonna pass a private key as private key.pam and enter. Okay, RSA UTL. Wait. Boom. I got the output as this is very sensitive file. My password is 120. This is a decrypted file. Correct? Got the idea how RSA actually, how public and private key actually works. Cool. Now, how many of you want to create a SSL certificate? Do you want to create your live SSL certificate self-signed? Yes or no?
Yes.
Yes. Actually, I'm also looking at the time because I have to also cover the web application test ticket. Oof. We have 25 minutes left. Are you going to perform with me? ओके एज चला हो जाएगा. ठीक है. Got pen now. Perfect. Gen RSA. Gen RSA. Gen PE. Okay, Gen peak it is. Just a minute. For SSL certificate, I'm gonna generate first a private key. I can use the same also. Request. One is new. One is key as a private key. I have in the back. Okay. CD like back. No, it's correct. Yeah. Request one is new, one is key as a private key, which is in the back. And I'm gonna save the output as certificate dot CSR. Okay, so what I'm gonna do is we are trying to make the SSL certificate, right? Okay, SSL certificate can be made using both algorithm RSA as well as AES, correct? So as we had already created a public key and private key using RSA, we can make a SSL certificate using RSA also. So the simple for SSL, what we have to do first, you have to request a CA for authorizing our certificate, correct? So for that, we have to create a certificate request file, correct? Okay. So for that, I am just trying to make a new file called as certificate.csr, where I'm going to request a new SSL certificate. I enter the command as OpenSSL request, that is req minus new, because I want to generate a new, where I had passed my key as a private key which I was generated previously, and the output I want to store in certificate.csr. Or on enter, it's gonna ask me few questions. So as I asked you while requesting for a certificate, it's gonna ask us the questions like our nation, our country, state, CNAME, email address, and all the stuff. So I'm gonna ask a few questions. The first question is asked is country name. I'm gonna pass it IN. IN represents India, correct? Now you're gonna ask what are the state or province's name. My state name is Maharashtra. Next city, Mumbai. Organization, you can enter any of the organization name you want. So if you are creating a SSL certificate for your organization legitimate, so you have to pass your original organization name because they're gonna verify it. But if you are doing it for learning purpose, you can pass anything. So I'm gonna pass same. Internet Private Limited. Okay. Organization unit name, I'm gonna pass tag. Common name, that is CNAME. Okay, CNAME is gonna be, let's say, localhost. It asking my email address. For now, we can pass any of the email address, ashutosh@gmail.com. And a challenge password. So for the password sake, I'm gonna pass 120. Option company name, pick company, and done. Here we had created a CSR file. In CSR file, we had submitted all the requests we want to send to a CA, that is certificate authority, to like provide us a SSL certificate for our domain. Okay. But in this case, if you want to like legitimate getting us SSL certificate from any third party, that is GoDaddy or something, you can pass this CSR to them also. They can also provide you SSL certificate. But if you want to create your self-signed SSL certificate, you can also create it from here. For that, you have to use OpenSSL's feature called as X509, where you have to first enter the request days. I'm gonna request it for valid up to 1 year. Then you have to pass your input as your CSR file, that is certificate file. Okay. Then you have to pass your sign key as your private key. So my private key is in back directory, which is back. So that's why I'm entering like this. After this, you have to pass like you want to store the output in which format. Okay. So I'm gonna store my output into SSL certificate.pem, and it's done. Perfect. Any question? What we did, let me just recap कि हमने SSL certificate ऐसे generate किया. First, we have to create a public key and private key. That's basic. You can create public key, private key with RSA or AES, any of that. I had created public key, private key using RSA. Okay. Once you have private key, you can create your request for certificate, that is CSR file. For that, you have to enter the command, this one. It goes here, yeah. OpenSSL request minus new. Sorry. Where you have to like enter this command, and after that, it's gonna ask you a few questions like what's your nation, state, and all other questions. You have to answer them and save the output into certificate.csr of any name.csr file. Correct? Then, if you want your certificate from any third party, you can send this CSR file to that. Or if you want to self-sign your certificate, because if you suppose you have purchased a domain, and along with the domain, you are not getting SSL certificate. So you have to pay yourself or more bucks, right? You have to pay more for SSL certificate extra. But if you want to use your own SSL certificate instead of buying new, you can do that also. You can create your self-signed certificate like this, and you can upload the certificate on your website so that your website will be hosted on HTTPS instead of HTTP. Correct? Great. So we have created the SSL certificate right now. Now we're going to verify whether our SSL certificate is correct or not. So for that, we can use this X509 is nothing but it's deal with the SSL certificate stuff. I want to check the output into text where I'm passing my input as a certificate, SSL certificate, and okay, no out is not like this. Is something like no out. Cool. So here is my SSL certificate. So whenever you will check any of the SSL certificate, what it contains your public key. It contains your data like your signatures when it's valid up to your CNAME, your location, your email address, location in the sense your country name, state, your email address, all the data of the SSL certificate holds. You can check from here. Correct? You can use this same SSL certificate on your any of the domain if you want. You can also use this certificate on a local host. If any of you are working in the class, you can easily use this certificate by using a parameter called as cert equals to in a main folder. In a Flask, when you start the server, also not in the Flask, you can also use an Apache servers, using Nginx. You can host your local host on HTTPS using these SSL certificates. Okay. So last 15 minutes left. Okay, 13 minutes. Yeah, 47 it is. In which we are going to talk about a bit about web security. Okay, because that was also one of the topic we have to cover today. So a bit overview regarding what is actually a web application security is. Okay. Anybody having any question regarding cryptography till now? Any question? For the audience who are online also, if you have any question, you can just ping in the comment. No questions. या तो मैं टीचर अच्छा हूँ या तो कुछ नहीं समझे. Cryptography clear है? If anybody can ask you, if anybody will ask you what is cryptography, what is difference between them, what is symmetric keys, asymmetric keys, you can answer it. You are able to answer it, right? Correct. Great. Fine. Now, before ending the session, we have to talk regarding the web application security. So, how many of you are bug hunters? Bug hunters, only one. Okay. Do you know about any of the vulnerabilities? Have you heard about any of the vulnerabilities? Name of any vulnerabilities you can count? Or should I stop sharing the screen? Okay, great. I don't have a new laptop now. We are going to talk about web application security. So in web application security, what we deals with is like while talking about web application, it contains all of the websites, active directories, the servers, correct? So when dealing with that, there are various vulnerabilities present over there. If you can count off a few vulnerabilities like OAuth top 10. Have you heard about OAuth top 10? No? Oh, laptop okay. The thing is, OAuth is nothing but organization you can say we deal with to managing the vulnerabilities, top 10 vulnerabilities from the year, which has been like reported on our websites. When you talk about the websites, there are various vulnerabilities present over there. We can easily find vulnerabilities like XSS, CSRF, SQL injections. Have you heard any about it? इनमें से किसी vulnerability के नाम कभी सुना है? जल्दी से किसी न्यूज़ में कभी आया हो कि SQL injection हुआ, data leak हुआ, SQL injection है, और XSS, directory listing, sensitive data leakage, data breach, correct? So these all things are nothing but the vulnerabilities which can be found on websites, and also web application is very fascinating domain in which what we have to do. There is actually career opportunity also present over there for testing a web application, that is WAPT we say, web application penetration testing, in which we have to find the vulnerabilities on our websites. So when you're talking about the vulnerabilities on our websites, we are talking about the various vulnerabilities like XSS, like SQL injections, like directory listing, and various different injections like HTML injection, LDAP injections, XML injections. There are multiple vulnerabilities you can check upon. The multiple exploits over there. And when we are talking about the exploits and vulnerabilities of web application security, we are talking about thing is Anybody of you can explain you what is vulnerability actually? What is vulnerability? Simple. Most of you are from cybersecurity, but only, right? What is vulnerability?
Flaw.
Sorry?
Loophole.
Flaw, loophole. Anything more? Bugs. What is vulnerability?
Can be interpreted by something. Interpreted, that can be interpreted, anything that can be interpreted.
Interpreted, mistakes. Okay. When you're talking about the vulnerabilities now, what I say is vulnerability is nothing but a case scenario or a part which we don't consider while developing a website. Just a minute. I guess so my. Okay. Fine. So when we are talking. Yeah. Wait a minute. Okay. So what I mean that vulnerability is nothing but a part or a case scenario which we left off. For example, I make a login page, or let's say I make a contact form using HTML, correct? Okay, it's very simple. HTML form where user will come. He's supposed to enter his first name, last name, email address, phone number, and submit. That's it. A simple basic HTML form. Okay. What a case scenario developer thinks when he's developing a HTML form. He thinks, okay, I have made a name. I mentioned your first name. In front of that, I have mentioned an input box. Second, last name, input box. Phone number, input box. And the end, as I have mentioned, the submit button. On the submit button, I added a function that is like whenever clicked on this, it's gonna pass all the data in a JSON format to my backend and it can be saved in a database. Correct? This is a basic mentality of the developers. Where they lag is that when a normal person will come, he's gonna follow that flow. But when a hacker come now, a part of inserting the first name, he's gonna try everything. What I mean, when a normal person come for the login page, that's a normal HTML form. In the name of first name, he's gonna enter his first name. And next, that is last name, next, phone number, done. But when the hackers come, he gonna enter everything a part of his first name, a part of what the actual there should be. Correct? What he can try to enter? He can try to enter some JavaScript code for alert. I guess everybody know alert, that is alert bracket में string में 1 2 3. Correct? What we're gonna do? हम alert functionality अपने website में use करते हैं to get some pop-ups. Correct? When user enter a wrong username passwords, we want user to get a pop-up. That username password is wrong. Correct? But when you make a HTML form in which if I enter JavaScript and on submit that JavaScript gonna execute, that's a completely different scenario now. Developer never think कि भाई कोई बंदा अगर JavaScript में code डालेगा in the place of first name. That's what actually the vulnerability is. That's where the developer lags and that's where we exploit it and we call it the vulnerability, the flaw, the bugs and all the named. Correct? It's just the matter of thinking of different perspective, different case scenarios which can be possible over there. Take a second example. While we are making a login flow, we make a payload for SQL, like query, not payload, query. Is that whenever user come and enter the username and password, in the backend we're gonna execute a query. Okay, I'm gonna take 2 minutes. In the backend, you're gonna execute a query like select user from username, username enter किया वो, where user equals to this and password equals to this. Correct? Correct. According to developer, he is proper. Code is working, and the rule is when the code is working, don't touch the code. Yeah. Correct. This is where they lag. When a hacker come, he is not gonna like follow the flow. He's not gonna enter the correct password. What he gonna enter? As any random name or 1 equals to 1. It is logical error and goes in SQL. It becomes a SQL query where it gonna show is like ये अगर exist नहीं करता फिर भी वो true है. And gonna execute and जो भी output आएगा render करेगा. That's a completely different case scenario which developer never thinks of, and that's where the vulnerability comes and hackers come and exploit it, and many of the things happens. So as a developer, what you should take care of is like you should take care of secure coding, right? What a secure coding mean is whenever you're developing any of the product, any of the website, any of the application, think upon the different case scenarios. Allow the thing which should be there. Like say if मेरा username है सिर्फ first name है सिर्फ letters allowed है, तो मेरे को सिर्फ ABCD डालना है ना, अपना नाम डालना है, वहाँ पे numbers और special characters क्या मिले, कोई जरूरत ही नहीं है ना. Then why should I allow a user to enter numbers and letters over there? I should put a check over there. I can do a proper serialization over there. कि whenever user enter anything apart of letters, it should show error. It should not proceed directly. Correct? So that's the proper way he should think of. कि like मेरे को जितना access देना है मैं उतना ही access दूँ. Why should I give you extra access? It's just like कोई उंगली पकड़े उसको हाथ पकड़ा देना. यूजर का फर्स्ट नेम लेना है, आपने पूरा ब्लैंक छोड़ दे भाई, कुछ भी डाल दो. I'm gonna enter it as the first name. Right? So when you're talking about web application security, there is a lot more. You can try all those stuff. I'm gonna recommend you few of the websites like Portswinger. Have you heard about Portswinger? Portswinger? No. So Portswinger actually is one of the famous website. Bubsuit is one of the famous tool which is developed by Portswinger, and Portswinger provides the labs that you can practice your web application security. They provide a very better lab actually. If you want, I can just give you a glimpse of how Portswinger looks like. On screen visible, right? This is Portswinger. Okay. Here in the academy, you can try. You can after login, you can try various labs, and you can go for it. Right? Any question? Any Q&A? Anything? Nothing? How's the session? Samla? And also, if you have any question, you can reach out to me on the LinkedIn, I mean Twitter.
I take the feedback form.
Is the Thank you so much, sir, for sharing your valuable insights in the field of cybersecurity. Now, I would request Ruchit Doshi and Dhruv Trivedi from IIC technical team to honor us, sir, with a bouquet. Guys, clap. Please fill the feedback form. Thank you.
Thank you. We can have a group photo. Then you can.
Guys, आगे आ जाओ.
जल्दी
Guys,
Guys, please. Some of you get bank comments. छोटे लोग
Yeah.